Okay, guys, this is Mr. Thompson, and we're kind of getting started on the Unit 11, which is reactivity. We're going to start it out by talking about some acids and bases. We've already talked a little bit about this, so we're just going to kind of review. An acid is an ionic compound that contains hydrogen and produces ions. So we get the H plus when you dissolve it in water. It's going to break apart. We're going to get all these H pluses floating around. A base, with our first definition, is when you dissolve it in water, it has a lot of OH, anions. So anions, remember, those are negative. So acids produce the H plus, bases produce the OH minus. And these acids and bases are called arrhenius acids and bases. So this is a vocabulary term that you're going to want. They're arrhenius acids and bases. Okay? Now, a little bit more about arrhenius acids. These definitions work awesome most of the time. The problem is not with the acids. Acids will be fine. They will always produce that H plus ion, but not all bases produce OH. You know, if you think about acids and bases that you may be familiar with, think if you can come up with a base, a common base. You have got this in your house most likely, okay? Think about what goes well with vinegar, especially when we're doing science experiments and things. And so if you say baking soda, that's an excellent response, okay? Now, the formula for baking soda is NaHCO3, sodium bicarbonate. The problem with that is sodium bicarbonate does not have hydroxide in it. It does not produce an OH anion. So how is it still a base? Well, it is still a base. It's just not an arrhenius base. That definition doesn't work well for us. There's a better definition for acids and bases that we want to use. An acid is something that donates a hydrogen ion when dissolved in water, and we're going to change the base definition. A base is a compound that will accept or take a hydrogen ion when dissolved in water. So instead of talking about hydroxide, we are just going to focus on H. We're just going to focus on H+, the hydrogen ion. And we're going to name these after the scientists that worked on this. We're going to call those Bronsted-Lowry acids and bases. Okay? So take a look at this reaction. Let me kind of demonstrate this for you and see. Here I have an acid that is hydrobromic acid, okay, combining with baking soda, sodium bicarbonate, our base, all right? Now, this is going to form a salt. Be careful, guys. This is not table salt. We know table salt is sodium chloride, okay? This is sodium bromide, but it is still called a salt, just not table salt, okay? So it's going to form that, and it's also going to form, well, we'll talk about that in just a second. Here, take a look. This acid is going to donate this H plus ion, and the base is going to accept it. And when that happens, they are going to form this stuff. Well, that is just carbonic acid, okay? But carbonic acid actually breaks apart really fast and it forms H2O and CO2, both of which are really harmless. This is neutralization that's taking place. We'll see that in just a second. One thing to note, because it produces carbon dioxide, those are the bubbles we get to see. Okay? So, like I've mentioned, this reaction is called neutralization. An acid is made weaker or even harmless by the other, or the base. If we're dealing with a strong base, we can neutralize it with an acid. Okay? Bronsted-Lowry. These are Bronsted-Lowry acids and bases. Okay? And Bronsted-Lowry covers all acids and bases. Arrhenius only covers hydroxide bases. Okay? It does cover the acids, but it only covers hydroxide bases. You will need to know both of these terms and the difference between them. Arrhenius talks about hydrogen ions and hydroxide ions. Bronsted-Lowry only talks about hydrogen, and it talks about donating hydrogen or accepting hydrogen. Okay? This is a real quick fun fact. To tell the difference between an acid and a base, if it's just sitting there in something, we use litmus paper. Litmus is an actual dye that comes from a plant. And what's interesting about it is if you drop it in an acid, it turns red. It turns the whole solution red. If you drop it in a base, it turns the whole solution blue. So this is how we use litmus paper, is we dip the little paper in there, and if it turns red, it's an acid. If we dip it in and it turns blue, it's a base. So you know I can't let you get away without having to do some calculations. So let's talk about pH. Okay. Now the stronger the acid is, the more H plus ions are in it. The stronger a base is, the less H plus ions are in it, because the base keeps accepting them and gets rid of them. Okay. So we have a formula to let us know just how strong an acid or a base is. And this is the formula right here. pH, which is the strength, it is the amount of H plus ions are in there, is equal to this. Now this is going to go in the calculator. Negative log, there is a log button on your calculator of this right here, H plus in brackets. H plus is the amount of moles per liter of hydrogen. It is the concentration of hydrogen in there. So let's take a look at some examples. Okay, we have 3 examples right here. Okay, what is the pH? What is the pH? What is the pH? And see how it gives it to you. It says, hey, we contain this many H plus ions. Okay? Well, we just take the log of that. That's it. And it gives us a pH of 2.88. Okay? Do the same thing on the next 2. pH equals the negative log of this number right here. And each time we get a different value. So what does all of that mean? Well, our pH scale is going to range from 0 to 14. Okay? Substances that have a pH that is 7 or below are acids. And the lower the pH, the more acidic. A pH of 1 is really acidic. Okay? If it has a pH of more than 7, from 7 to 14, those are bases. The closer something is to 7, the closer it is to water. Water has a pH of 7. And so if an acid or a base is really close to 7, it's really weak. Okay? Now take a look at some of these common substances that you may find. You may find some of these around your house, you may not. Lemon juice. Lemon juice is an acid. And it has a pH of 2, so it's pretty acidic. Okay? Vinegar, which is also an acid, is not as strong as lemon juice. It only has a pH of 3. And did you know that milk is an acid? Milk has a pH of 6. Now that's not very strong at all, but it's still an acid because it is still below 7. Whereas some of these things down here, baking soda, of course, is a base. Baking soda has a pH of 9. It is above 7, so it's a base. Tums, which you may know as antacids or anti-acids, well, the opposite of an acid is a base, so Tums are a base, and they have a pH of 10. So they work really well at neutralizing the acid in your stomach. And this right here, Drano, a drain cleaner, drain cleaners are typically really strong bases. And if you notice, this has a pH of 13, and the maximum is 14. So you can see that's quite a bit. Okay? We'll have some practice in class tomorrow. Make sure you guys write down all these notes, and I'll see you guys then.